So we're going to have a look at what happens with recurring decimals, and how do we know with long division that recurring decimals are recurring decimals. So let's consider this example, 7/36, which means how many times does 36 fit into 7? That's what this notation is telling us. So depending on where you're from, what your background is, you'll have seen this technique used probably with different notation, or maybe the same. But this is what this is saying. How many times does 36 fit into 7? And of course we know the answer to that question is none. It doesn't fit in there at all. So we know we're dealing with a part of a number here, so I can put my 0 on a decimal point because I'm going to have to shift a place value to the right now and consider how many times 36 fits in to 70, and then I have my answer one decimal place to the right. And of course it fits in there one time with some remainder. So I'm going to put a 1 there and say, well, 1 lot of 36 is 36, which gives me a remainder of 34. And obviously 36 doesn't fit into 34, otherwise it wouldn't be a remainder. So I need to take one more move to the right on the decimal places. So I'm going to put a 0 next to 34, make that 340, and my answer here will take a corresponding step to the right across the top there. So how many times does 36 fit into 340? A bit trickier to do, but if it was 360 that would be 10. So that helps me estimate. I think the answer is going to be 9, and then I can quickly do 9 36s and find out that I'm right. So 9 times 9 36s add up to 324. So that's going to leave me with a remainder of 16, which I've still got to deal with. So that's my remainder there of 16. And of course 36 doesn't fit into 16. So I'm moving again another decimal place to the right, making that 160. How many times does 36 fit into 160? Well, that goes 4 times before I have with a remainder. So 4 lots of 36 is 144. That's going to leave me with a remainder of 16 again. And so I would go through the same process there, put my 0 on, move another decimal place to the right, and think, hold on a minute, last time I did this, yeah, there were 4 36s are 144. That's going to leave me with 16 as a remainder. And so I can see that that's just going to loop now. That's just going to repeat. And I'll just keep putting 4s on the end. So we've now shown that that's going to be 0.194 recurring, where the 4 is the recurring digit. Okay, so it's the same process, converting a fraction to a decimal by long division. But with recurring decimals we get into this loop, and we can quickly tell when that's going to keep recurring, and therefore conclude that it's a recurring decimal as the answer.